Now that you have learned the foundational Linux commands, pwd, ls, cd, and how to interpret paths, it is time to go deeper. Mastering navigation in a Linux terminal is not just about knowing the commands. It is about understanding the subtle mistakes that even experienced users make, and how those mistakes can become critical issues in a cybersecurity context. This chapter focuses on the most common navigation pitfalls, explains why they happen, and shows you how to avoid them. Why navigation errors matter in cybersecurity. In a standard office environment, making a navigation mistake in the terminal might mean you edit the wrong file or run a script in the wrong folder. In a cybersecurity or DevSecOps context, the consequences are far more severe. Running a command in the wrong directory during a penetration test could overwrite logs, corrupt evidence, or even trigger alerts on the target system. Misconfiguring a path during a deployment pipeline could expose sensitive credentials or bypass security controls. Understanding and avoiding navigation errors is therefore a foundational skill, not just a convenience. Pitfall 1. Confusing absolute paths and relative paths. This is the single most common source of confusion for beginners, and it remains a trap even for intermediate users. An absolute path always starts from the root of the file system, represented by a //. For example, /home/alice/documents/report.txt always points to the same file, regardless of where you currently are in the file system. A relative path, on the other hand, is interpreted starting from your current working directory. If you are currently in /home/alice and you type cd documents, the system looks for a folder called documents inside /home/alice. If you are in a different directory, cd documents will look for documents there instead, and may fail or navigate to an entirely different location. Example of the pitfall: you are working on a penetration test and you have a script located at /op/tools/scanner/run.sh. You open a new terminal, and your working directory is /home/user. You type /scanner/run.sh, expecting it to work. It fails because there is no scanner folder inside /home/user. Always use absolute paths when writing scripts or automation tasks to guarantee predictable behavior regardless of where the terminal session starts. Pitfall 2. Misusing the tilde character. The tilde character is a shortcut that refers to the home directory of the currently logged in user. For example, if you are logged in as Alice, then tilde expands to /home/Alice. However, a common pitfall occurs when scripts are run as a different user, or when the root user is involved. If a script runs as root, the tilde resolves to /root, not to /home/Alice. This can cause files to be written to unexpected locations, or commands to fail because the expected directory does not exist under /root. Another subtle trap: if you use the tilde inside quotes, it may not be expanded. For example, cd tilde/documents will not navigate to your documents folder. It will literally try to find a directory named tilde/documents, which does not exist. Always use the tilde outside of quotes, cd tilde/documents. Pitfall 3. Overlooking case sensitivity. Linux file systems are case sensitive. A folder named Documents is completely different from Documents or Documents. This is in stark contrast to Windows systems, where file and folder names are case insensitive. Example of the pitfall: you create a folder called Logs during a security audit to store your output files. Later, you type cd logs and the terminal returns an error, no such file or directory. You might spend minutes wondering what went wrong, when the issue is simply that the folder is named Logs with a capital L. In a DevSecOps pipeline, case sensitivity issues can cause entire build stages to fail silently if configuration files reference paths with incorrect capitalization. Develop the habit of always verifying the exact name of files and directories using ls before navigating or referencing them. Pitfall 4. Hidden files and directories. In Linux, any file or directory whose name starts with a period is considered hidden. These files do not appear when you run a plain ls command. To see them, you must use LSA, which stands for all. Hidden files and directories are extremely common in a security context. Configuration files for tools like SSH, Secure Shell, Git, and Bash are stored in hidden files such as SSH, bashrc, and gitconfig inside the user's home directory. Sensitive data, including private keys, access tokens, and shell history, are often stored in these locations. Example of the pitfall: a junior security analyst is exploring a compromised system and runs ls in the home directory. They see nothing suspicious. However, running LSA reveals a hidden directory called malware containing scripts used for persistence by an attacker. Always use LSA or LSLaw when investigating a system or reviewing a directory for completeness. Pitfall 5. The double dot and single dot confusion. You already know that, refers to the parent directory, and refers to the current directory. These are called special directory entries, and they exist in every directory on a Linux system. A common pitfall involves accidentally using, when running executables. In Linux, the current directory is not included in the command search path by default. This means that if you have a script called scan.sh in your current directory and you type scan.sh, the terminal will return a command not found error. You must explicitly tell the shell to look in the current directory by typing /scan.sh. This behavior is intentional and is a security feature. If the current directory were included in the search path automatically, an attacker could place a malicious program named ls or cd in a directory and trick an unsuspecting user into running it instead of the real system command. Pitfall 6. Spaces in directory and file names. Spaces in file or directory names cause significant confusion for beginners. If you have a folder named My Projects and you try to navigate with cd My Projects, the shell interprets My and Projects as two separate arguments and returns an error. To handle spaces correctly, you have two options. Wrap the name in double quotes, cd My Projects. Escape the space with a /cd My Projects. In a professional security or DevSecOps environment, it is strongly recommended to avoid spaces in names entirely. Use underscores or hyphens instead. For example, my_projects or my projects. This avoids ambiguity in scripts and command pipelines. Pitfall 7. Navigating as the wrong user. Linux is a multi-user operating system with strict permission controls. A very common pitfall is navigating to a directory and trying to list its contents or run a command, only to receive a permission-denied error, because the current user does not have the necessary rights. This becomes especially important in penetration testing and system administration. When you escalate privileges using the sudo command, which allows you to run commands as a superuser or switch users with su, substitute user, your current working directory may not change, but the permissions available to you do. Example of the pitfall. You are logged in as Alice and you navigate to /root. The system allows you to enter the directory in some configurations, but when you try ls/root, you get permission denied. You switch to root using sudo su, but now your working directory is still /home/Alice, not /root. Always confirm your current directory with pwd and your current user with the whoami command after switching users. Pitfall 8. Symlinks and unexpected destinations. A symbolic link, often called a symlink, is a file that points to another file or directory. When you navigate into a symlink directory using cd, you may end up in a location that is very different from where you think you are. Example of the pitfall. You see a folder called logs in /var/app/. You do cd/var/app/logs and then cd, expecting to return to /var/app/. Instead, the terminal takes you to /var/log, because logs was a symlink pointing there. Using pwd will always show your logical path. To see where a symlink actually points, use the command lsl, which displays the target of the link. In security auditing, symlinks can be used deliberately by attackers to mislead administrators or cause programs to read or write files in unintended locations, a technique known as a symlink attack. Pitfall 9. Assuming the same environment across sessions. Each new terminal session starts fresh. The current working directory is always reset to the user's home directory when a new terminal opens. Variables set in one session, aliases defined, or directories navigated to are not preserved unless explicitly configured. A pitfall common in DevSecOps automation. A developer manually tests a script in /ops/tools/ and it works. They then add it to an automated job, such as a scheduled task or a continuous integration pipeline, without specifying the full path. The automated job starts from a different working directory and the script fails. Always use absolute paths in scripts, configuration files, and automation pipelines. Never rely on the assumption that the working directory will be the same as it was during your manual testing session. Summary of best practices. To avoid the pitfalls described above, adopt the following habits from the start. Always verify your current location with pwd before running sensitive commands. Use absolute paths in scripts and automation to guarantee consistent behavior. Use ls/law regularly to see all files, including hidden ones, along with their permissions and types. Never assume that the current directory is in the command search path. Always use. To run local scripts, be careful with spaces in names. Prefer underscores or hyphens. Verify symlinks with lsl before navigating into them. Confirm your current user with whoami after switching users. Remember that Linux is case sensitive. Double-check names before referencing them. These habits are not just good practice in a security environment. They are essential to maintaining control, avoiding mistakes that could compromise an investigation, and writing reliable, secure automation pipelines.